Okay, not as much time today because I'm doing some game dev stuff, just broadening the horizons. But I'm doing the coding all I can. I'll do game dev stuff this weekend. My own private stuff. Haven't really done it in a few days because coding is really all that matters right now. I have enough of a foundation in game dev to work things out. I just need to get a good foundation in programming now. So where were we here? We were in local variables and nested blocks. What? Linkage. Hold on. Yeah, here we go. Okay. So we had automatic storage duration. Yeah, the created definition destroyed at the end of the block that they're in. Cool. Yeah. So created here, destroyed here, created here, destroyed here. Okay. Nested blocks. Define inside nested blocks. Oh, wait. Actually, so we were at the end of this. Okay. Nested blocks are considered part of the scope of the outer block in which they define. Hold on. So the scope of variables inside a nested block is only inside that block. But the scope of variables in the outer block can be seen inside a nested block. So anything defined out here can be used here. Okay. The writing here is kind of wonk. It says the nested blocks are considered part of the scope of the outer block in which they're defined. Nested block is defined here, which makes you think y is initialized here. It's specifically list initialized with the integer 7, the literal const. Well, yeah, the const literal. It can't be used here because it is not within scope here. 5 is in scope here, but y is not in scope here. Let me see that. Okay, fast. Missed the plane. Might have been a helicopter. That was crazy sounding. Identifiers. Okay, so yes. Yeah. Y can't be used here because it's out of scope. So in here, outer block, enter scope. Enter scope. X and Y are both in scope. We can output both. Y goes out of scope. Y is not usable here. Okay. Linkage. Whether a declaration of the same in a different scope refers to the same object or not. So linkage would be local variables have no linkage. But some things do have linkage then, huh? Oh, so like a global variable, for example, maybe? Each declaration of an identifier with no linkage refers to a new unique object or function. Yeah. Hmm. Yes, the scope defines whether they're usable, but linkage determines whether they're the same thing. So they're just two different things. They measure different concepts. Just like mass and height are different. So this is one scope. Scope level 0, we'll say, for main. X is within scope 0. This X is a different one. In scope level 1, as you go down in scope, the lower level, or as you go, I guess, deeper in scope, the lower levels, or the outer levels, are accessible within the inner levels. So this X here, wouldn't you get a multi-definition issue here? Yeah. Wait, hold on. Oh. Oh. Oops. It's actually okay. Because it's not a multi-definition because it's in a different scope. But there are two local variables that are the same here. Okay. I wonder if it would give me the same thing if we had a for loop. The declaration of x hides the previous local declaration. Ah, yeah, because when I declare this guy here, I then can't refer to this guy because I don't have, there's no, it's not in, it's still within the global namespace, so I can't access him anymore. Oops. Nope, that's not it. That's not it. Oh my fuck. Okay, we're good. Scope determines where it can be seen and used. Linkage determines whether they're the same object or not, whether they refer to the same object or not. Okay. Okay. Name hiding. Linkage isn't very interesting in the context of local variables. Okay. Yeah, it makes sense. Just for the sake of name conflicts. Makes sense. Made, outputted, gone. Nice. Oh, cool. So only create variables where they're used. Instead of having a variable here and then not using them. Yeah. Yep. Yeah, like if I could, if we only need x here, then I may as well just pass y to some other function and then update y if big enough. Like y is 5, and then we'll say this is your, like I'm an alien and I can adjust my height and my goal is to ride a human amusement ride. Why is this here? I don't know. I guess that makes sense actually. That's cool. I didn't think about this formatting where you have a space before a nested block. Not that I've ever used a nested block. But your goal is to ride a human ride. Excuse me. And I'm 68 inches tall. Here, well, let's make something make sense. Say I'm like fucking big. I'm 7 feet tall. So I have 84 inches here. What is that, right? 12 times 7. Yeah. So I'm 84 inches tall. And then we pass this. We then pass is tall enough for adjust height if needed, and then we pass it y, and then there's a function that checks y and says, hey, we check to see what the player enters the ride height limit, how tall you can be, or the height limit. Yeah, you can't be any taller because there's literally not room on it. And if it says, oh, 74 is the limit, and then we say, oh, if, or we'll say it's 73, and we'll say if y, or we'll say whatever, if the parameter that this guy's getting, the argument in this case is y, is greater than the height limit, which is defined here and acquired from the player, then shrink the height by 1. So from 5 to 4, 74 to 73. Then we'll output it and say, okay, height has been adjusted. And the alien would have been like, oh, okay, I'm not tall enough. And just shrinks himself and then goes. So instead of putting that check here, this is basically just a function where we're acquiring input from the player and then checking something and then adjusting it. Instead, we may as well just do y and then compare with height and adjust if needed. And then after, boom, we only have 2 lines of code in here. Main is more simple. And then we have a function that we're calling once. So main is like 3 lines long. Or I guess 5 if you include the braces and the return. Yeah. Plus 1 for a space probably. Because I don't want it to be like boom, boom, return 0. I want it to be boom, boom, space, return 0. Okay. Better used as a separate function. Okay. So we'll say... Okay. This will be good later because I'll probably forget some of this by the time I do it. What do I have to do? Asks the user to enter 2 integers, one named smaller, one named larger. If a user enters a smaller value for the second integer, use a block and a temporary variable to swap the smaller and larger values. Then print them. Add comments to your code indicating where each variable dies. When you print them, smaller should hold the smaller and larger should put the larger, no matter which order they were entered. So enter 4 and 2, and it'll say swapping the values if they're smaller, and then say the smaller and then larger. Okay, so we need a function to get input. What are we doing? We're doing a nested one. Wait, aren't we? Hold on. Use a block and a temporary variable. Oh, wait, hold on. If that, then we'll swap. Oh, okay, so it's just a function. Okay, so first we need main to actually have a program. And then we need input and output. And we need a function. I'll do this in... We'll do it regular. Easy mode. Okay, I need a function that acquires input, stores it. And we'll just say it acquires input again, and then it checks, and then swaps. Okay, so if I just, what if we just do an integer, and then we'll just say get player integer, and we'll just call it no argument or no parameters, and then it'll just say int player int. And then we need to extract that to player int, and then return player int. Cool. And then we'll just say int smaller, and then we'll say get player int larger, get player int, and then we'll say we're going to output. Oh, 2 things different. So we're doing smaller, larger. Okay. All right. Swapping the values. And then smaller, larger, larger. Cool. So this is fine. What is happening? Why are we int smaller in this? Int get player int, get player int. We're saying there's an int. We're extracting it and then we're returning it. What's an issue here? We're having issues on line 13 and 14. Oh, whoops. I keep on forgetting to put the fucking parentheses for some reason. I don't know why. It's a stupid mistake I need to work on. Okay, so we say smaller and larger, but then we have a block. So we say smaller, created, instantiated, defined, declared here, larger, created, instantiated, declared, defined here. Excuse me. Smaller and larger destroyed here. And enter scope. And enter scope. Begin lifetime. Begin lifetime. Okay. And then we'll say player int enters scope and is created here. Player int return player int's value turned to main here. Oops. Main here. Player int destroyed here. Okay. And then we'll say this needs to be if smaller is, we'll do it only if it's greater. What are the contingencies? We're saying if it is smaller for second. So if, I guess we'll just say if larger is greater than smaller. Or oops, sorry, is if, we'll do if smaller is greater than larger. And then a block like this. That makes sense. Okay. And then we'll say int temporary int value initialized. And we'll say and we'll initialize them to be smaller. I guess we want to value, apparently the best practice is actually to value initialize and then we'll do the swapping. So we'll do temporary int and we will assign him smaller. Smaller is now larger. And now, or hold on, so we'll do temporary int is now smaller. Yeah. And now we have to say, so smaller passes his value off, takes the value, and then we pass it. So smaller is now larger. And now larger is temporary int. And now we'll output it. Cool. So if we say, oops, didn't prompt the user. Oops. Enter an int. Oops, we'll also say temporary int enters scope and created here. Temporary int, oops. Temporary int destroyed here. And it's not accessible here. Temporary int not accessible here or after. Here, after. Since nested scope isn't within, since inner nested scope isn't within outer scope. Oops. I accidentally put a T. Okay, so we say enter an int 4 and 2. swaps the values 2 and 4, 1 and 66, 1 and 66. Oh, oops. Say, where did I put swapping the values? Oh, oops. It's supposed to be, that was stupid. Then put swapping the values. Oops. Cool. So we'll say 1 and 66. And then we'll say 66 and 1. Swapping the values, smaller, larger. Cool, it works. Okie dokus. And apparently this guy is a type of IO stream, or type O stream. I think I can do like that. Oh, there's input and output streams. That's cool. That makes sense. That's why we're including it. It's those types. Yeah, and it's a type of O stream. That's cool. Okay. The character output stream. So we have to get the value, and then print smaller and print larger. But if smaller is actually larger than larger, then instead we swap the values. Well, how do we do that? We create a temporary variable. He stores smaller's value, which then smaller can get larger's value because its value is already stored elsewhere. And then once smaller has larger's value and is now smaller, larger can now get smaller's old value, the actual small value, from temporary int. And then temporary int is destroyed here. Cool. What do we want? Temporary int. We don't want to be, I mean, we could initialize them and make them const. So maybe we do these guys are being changed, so these can't be const expressions. This guy, however, could just be a const expression int. And that's because, let me make sure. Never mind, because smaller. Never mind, because player int doesn't have parameters that are known at compile time. Therefore, it cannot return a const expression. Oops. Okay, so we're saying variable. We're getting the variables. Cool. We're checking to see, is smaller actually smaller? It's not. Or if we say if smaller is, oh yeah, well, that's it. So if, or we could say if not smaller less than larger, one 60 or 55, 1. We have a temporary variable. That way we can store smaller. And then we can pass larger to smaller, and then temporary int to larger, and then we're good. We have swapped them. And then we print them afterwards. Anything special? Oh, there's a swap. Oh yeah, because then we can do it without actually storing it like that. Anything else? Where each variable dies when you print. Yep, cool. Okay, so we're saying, oh, you didn't have a function? Weird. So you said 1, 2, you just violated DNY, or DRY, don't repeat yourself. And if your user did it wrong, if smaller is larger than larger, you say swap the values, you say temp, and we initialize them to be larger, and then list initialize them, to larger. And then larger is now smaller. Smaller is now temp. Either way. And then we output smaller. Smaller, larger is larger. I prefer doing it like this. But that makes sense. Oh, oops. I didn't mean to do that. I'm going to try and use like that. Oops. Dang, I was hoping. We could do that, and we'll say int, temporary int. Oops, that is a copy assignment, but also copy direct list. I don't even know what this is, dude. Smaller, and then we can paste. Boop. That way we value initialize them once he exists. But if he's not known at compile time, well, he's getting changed, so he can't be const anyways. Cool. Okay. That was fun. And now I could do, you could use standard swap from utility to swap the two values. And you pass it both? Yeah. Larger, smaller. What if we do that? Let's try that. And then we'll do, it's actually afterwards. Include utility, please. And we'll just say standard swap, smaller, and larger. Oop. 166, 66, 1. Cool. That's fun. What type is swap? Oh, I guess it's a function. Duh. It's a void. Doesn't output anything. It's a const expression void. Interesting. And it passes two integers. Or it has two integer parameters. That's cool. Okay. Difference between a variable scope and duration. Well, the question between duration and lifetime, apparently for local variables, we'll start with duration and lifetime, since they both describe how long a variable is alive, not where it's usable. Excuse me. They're kind of similar, just scope, but we'll start here. We'll do an order just for hardness instead of doing it how I want. No, I'll do it how I want. I don't care. So lifetime. Lifetime is the duration. Well, sorry. Lifetime is the length of time that a given variable is instantiated in memory. So it's the time between its creation and its destruction. So, at least for a local variable. Well, no, it's the time from its creation to its destruction. The duration for a local variable is usually the same as its lifetime. Duration is from its definition to its destruction. Or, well, I guess from its declaration maybe to its destruction. But for other variables, it might not be the case that... Oh, actually, duration's probably the shorter one. So maybe duration is the time between its creation and destruction. But it could transverse across. It could be across scopes versus lifetime is within one. Let's see. Duration might be the length of time that a variable is usable, or a lifetime might be the duration that a variable is usable. Whereas the other is the amount of time that it's in existence. Scope is the area in code within, sounds like within a namespace maybe. Scope describes where a variable is accessible and usable. So if I have one namespace and a namespace within it, and I define a local variable in there, this scope is from the opening brace to the closing brace. It is not within the outer block scope. So a variable defined within the inner block is not usable within the outer block scope because its lifetime is between these curly braces, not these curly braces. But if it was instead created during these curly braces, nested code blocks are within the outer code block. Therefore, the outer code block's scope is usable within the inner code block. So we can actually define x here and then use it in here. And then this variable out here can be changed by in here. So like it's 3, now it's 4, and then now we print 4. Cool. The scope defines where it's accessible within the source code. The duration defines the rules that govern when it is created or destroyed. So the lifetime is the actual time between its creation and destruction. The duration defines the rules that govern when it is created and destroyed. Okay, so you could have a global variable that has a lifetime. It's created and destroyed. It is accessible within a given scope. But the rules that describe its lifetime, when it actually gets destroyed, and when it gets created and when it actually gets destroyed, just like a C-style string literal is created at some point. I think at compile. Oh, well, I guess it's created. I don't know. Well, upon creation, its lifetime persists until the end of the program. It is not simply destroyed at the end of the nearest curly brace, nor the curly brace in which it is created. So duration defines the rules governing lifetime. So the rules, variable is created here because some reason. Variable is not destroyed here because of some reason. It's actually destroyed here. So duration governs the rules. So duration is like how biology governs life. So like when an egg and sperm meet, right? Boom. Unique DNA is formed. Boom. There's a new human. The laws of biology describe that formation of the human when it is created. And upon the ceasing of all biological function, maybe in the human, I'm not even sure how you really describe death, because there are probably some things that persist after someone is gone. Maybe it's brain death. I think some places describe it as brain death. So once all cells in the brain cease functioning, just keep it easy. Once all cells in the brain cease functioning and are no longer active and are clearly dead, boom. Biology has defined that. So duration has defined that as the end of lifetime. Duration is defined for a local variable. The ending curly brace within the block it has been defined in as when it is destroyed. And it is defined the line it is instantiated in, declared defined as the line it has been created in. Duration describes lifetime. Scope describes where it's accessible. So scope, let's see. Scope defines where it could be used if it was created somewhere in there. So if it was created, scope is within the block, basically. Unless we're talking a function where the parameter is actually created in the parentheses above it. So it's usable in the block, it's accessible, it's in scope here, but it really gets created even before the block. So local variables have block scope, which means they're accessed from their point of definition to the end of the block they're defined within. Unless they're somehow destroyed before then, but it sounds like they're destroyed at the end of the block. Local variables have automatic duration, which means they're created at the point of definition and destroyed at the end of the block which they're defined. They're made here, destroyed here, even though it could technically have been created here and used even earlier than when it was, because that's the scope. Well, it's in scope. Here. Okay. Okay. Global variables. What? Oh, delete, not remove. Yeah. Some glasses now. Let's see what I even look like in the camera. I'm curious. Let's see. Is the mic even working? Mic's good? Yeah, I think mic's good. That is interesting. Oh, I smudged it. Fuck. Can't even really tell. Just a little. Holy, when you get the forehead going. Damn. Okay. Needed some Gojo glasses. Okay. Yep. They're created when they're at the point of definition and destroyed when the block is exited. It just so happens that when you declare a variable, it's actually created there. Declaring global variables. Oh, we have declaring here. Different term. GX. Why the fuck is that name? Oh, global X. I see. Whoa. And it goes out of scope after main. Hmm. Wow. But it's in the file. It would need to be declared in another file. I guess if we were going to use it here, maybe? I don't know how you would do that though, because it seems like if you declare a variable with just the variable's type, name, and a semicolon to make the statement, it's automatically default initialized from what I know. So, we can now have, excuse me, input and output. And we'll just have int z. Oh, oops. Okay. And then we could say, okay, so we have z. We'll just make z1. And then we have a variable called the thing. And it takes an int. Oh, oops. Oh, we don't need thing. So we'll just do nothing. So we're saying we have z, and it's going to say z is now 1. We're going to do a thing, and we're going to set z to be 2. We're going to output them. And then we're going to say one, 2, and 4. Oh, hold on. So we're saying there's z before the function, z in the function, z after the function, and then more. Cool. Z is usable here before the function. Oops, should have been a space. There's z in the function because we then call the function, we assign z a different value, and we print it. And then we check after the function to see what z still is. It is still z because we can manipulate z here. And then afterwards, z is now updated again. Use them everywhere. It's too cold. We're back. Oof. Oh no! Oh my god! I forgot. I made rice. And I fucking left the rice in the rice cooker the whole time. It's been in there for like an hour. Oh my god.